Alright, so we went through this table last time, and we filled all this out, didn't we?
Yes.
Yeah. And some of us were saying, hey, we had a pattern here, remember that? And we said, okay, well, when we go through all these shapes, and we say, okay, if we go through all of the diagonals from one point, we can figure out how many triangles are in this shape. So there's one triangle in this triangle, two in a quadrilateral, three in a pentagon, four in a hexagon, so on and so forth. It kept increasing as the number of sides increased. What do we notice about the number of sides compared to the number of triangles, though? There's two more sides than there are triangles. That means there's two less triangles than sides, right? We're kind of both ways there. So if we take our number of sides and subtract 2, we have the number of triangles for any polygon, any convex polygon. And the sum of the interior angles of one triangle is 180 degrees. So that means we can just multiply that 180 for every triangle for the number of triangles, and that's how we can get the sum of the interior angles. So because a pentagon has 3 triangles really inside of it, if we go from one diagonal, or one point, make all the diagonals, we can take 3 times 180 for one triangle and get 540 as our measure. And we're able to go through all of those. And so this rule we have down here is going to be n minus 2. We're going to take the number of sides, which is n. We're going to subtract 2 from that. So that'll give us a number of triangles. And we'll multiply that by 180. And that will always give us, always give us the sum of interior angle measures for any polygon, regardless of the size, regardless of how many sides it has. Any of that is always going to give us the sum of the interior angles for a polygon, as long as it's convex, pointing out, not concave, caving in. Okay, band students, you may go. So using this, we can end up finding the total measure of a polygon. Hey, you too, thank you. The total measure of a 55-gon. We can even find the total measure of the internal angles of a 55-gon. And we wouldn't have to do what we did the other day, where we go through and we measured it and we added it up on our polygons, our cutout ones. We wouldn't even have to do that. We could just put this into our formula, into our little rule there. And we could do 55, and what would we do with this number? Minus 2. Thank you, Gracie. We put that in for n, the number of sides. And so we'd get what times 180? 53 times 180. And somebody go ahead and do that math with the calculator. I know you guys have phones on you. Go ahead and get those out if you need to. Use one of my calculators.
9,500. I was just about to say that.
9,540. So that means for any 55-gon, 55-sided polygon, the total sum of interior angles would always be 9,540 degrees. And now, personally, I think that's a lot easier to do that, what we just did here, than if we were to go and try and cut out, like make and draw and cut out a 55-sided polygon and go through and actually measure those. I think this is a little bit easier. And we have this rule that we can always do because of how many triangles are in these. I think that's pretty cool.
I had one job.
Wait, where'd you get this guy?
I just made that one up. I just said, hey, here's a random one. We could have chosen anything. So we could have been like 2,840. And found it for that too. Pretty cool. Okay, let's see what's written down after lest we forget. So now, we're going to flip the page. We're going to go on to 6.2. And if we look over here at the sideboard over here, under Wednesday, my dudes. Music to my ears. SWBA does in fact mean students will be able to find and solve for angle measurements of polygons. Sorry that green's kind of faded. I've been having a hard time writing on that board. Any color was. It's kind of a drag. We're going to be able to find more angle measures for the polygons, both interior and exterior angle measurements. Okay. So, our polygon interior angles theorem, this is what we just actually talked about. The sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180. And is it important that I put the n minus 2 in parentheses?
Yes, because you did that first.
Because we do that first. Very good, Nathan. Because if we didn't have it in parentheses, then that would just be like we're taking this, and then what would you do first here? Then you would multiply first. But we don't want to multiply first. We want to subtract first. So we put that in parentheses. So in example 1, we're going to name, it says quadrilateral, that's a typo. It should be name the polygon and find x. So we have to name the polygon by the number of sides and say, okay, it has this many sides, so this is the name. And then find x, one of these angles. And this is a regular polygon, so all the angles are congruent, have equal measure. So how many sides does this polygon have? 12. So what would the name of that be? Dodecagon. Okay, dodecagon. It's like the decagon, but we have the do in front of it for 12 instead of 10. Now, how would we find just one of these 12 angles?
I just 12 minus 2
Okay, so 12 minus 2.
times. Wait, and put those in parentheses.
Okay. Okay, and what's this going to help us find?
And then you can
Okay,
12.
so Grace is saying, hey, this will help us find the sum of all of these angles in this polygon, in this dodecagon. And then if we divide by 12, why 12? That's how many sides and angles there are. Then we'll get each angle. We'll get that one angle. So go ahead in your calculators, do 12 minus 2 times 180.
We get to divide. Oh, I see.
If you guys need calculators, I have some up there. Okay, I agree with that.
What all the signs is
Okay, and so here's that sum we get for all of the angles. And so we said we just need to find one, so we're dividing by what number again?
12.
Awesome. And then what do we get here?
150.
150. Okay, so x is 150 degrees. If we're just finding one of the angles when they're all the same, you would. Because we said, hey, all the angles add up to this number, and if they're each the same, that means they're all 1/12 of that. Does that make more sense?
Yeah.
Right. It's just kind of like the idea if you find half something, you divide by 2. We're just finding a smaller portion. We're finding a 12th. Questions on number 1? Liddy. On number 2, this one is supposed to say name the polygon again, but it is a quadrilateral, so we'll skip that one. It's already quadrilateral. And find x. Would we go about this one necessarily the same way? No.
You have to find it.
Okay, we had to find x last time too, so what's different?
Equation.
Okay, I see some, we'll call them expressions since they don't have the equal sign, but I get what you're saying. We got 6x plus 50 and 6x plus 10. Okay.
Value of x.
We're supposed to find the value of x, okay? So, do we know anything about all 4 of these angles?
No.
Okay, Willie, what are you saying?
We just
Don't
kind of like make 2 shapes out of it, make that a triangle, and then put them all as 60 degrees.
So if it was an equilateral triangle, we could. So if we knew making a triangle here would make an equilateral triangle, then we could. But I don't think some of these angles are going to be 60 degrees, unfortunately. But I like that you're kind of thinking abstractly there. I like that. What do we know about quadrilaterals? What's the sum of the measures of a quadrilateral? 4 centimeters.
360?
360. Okay, how could we find that out if we don't have that one memorized?
Look in your notes.
Okay, look at our notes.
3, 6,
Could we also plug that into the n minus 2 times 180?
Yeah.
If we need to, we could do 4 minus 2 times 180. Get 2 times 180, which is that 360 we talked about. So if we don't remember that a quadrilateral has a total sum of 360 for all the angles, we can still find that out using this. So if you don't memorize that, that's okay. Don't panic on that one. If you remember n minus 2 times 180, you can get there. Now, what would be the significance of knowing that all four of these add up to 360? Emma?
Can you put them into an equation?
Okay, what kind of equations do you think we'd have?
Could you do like 6x plus 50 plus 6x plus 10 plus 2x?
I thought we got first.
Okay, so 6x plus 50 plus 6x plus 10, and then we need to add these angles, right? So what's this angle measured?
90.
What's this angle measured?
90.
So could we put plus 90
30 plus 1.
plus 90
Or plus 1.
or plus 180 because it's 90 plus 90? Okay, and what would this equal?
360.
360. So what we did was we added all four angle measurements, and we said it equal to 360 because we said we know that the sum of all four angles is 360. So that's what we're doing. We're doing the sum, adding all four angles is equal to 360. So how do we solve this from here?
You first. Let's combine like.
Here, let's first combine like terms. I like that. Okay. So what are the like terms that we have on this left side?
12x.
Okay, we have 6x and 6x. Okay, something I do in my Algebra 1 classes, I underline them with one underline for those. Those combine to be what? 12x. We'll add them.
And then I got 50,
Okay.
10, 99.
Then we have 50. I'll put two underlines underneath since these are different.
180 plus 60.
Okay, so 90 plus 90 is 180.
240.
Okay, this would end up being 240. Another way we could do that is put in a calculator, or you could think 90 plus 10 is 100. Plus 90 is 190. Plus 50 is 240. However, that helps you. Like I said, or you can put in a calculator, that's fine. Equals is still there, and 360.
12x
So-
equals
Minus 240.
So minus 240, and Gracie's already on that next step saying, hey, 12x will equal what, Gracie? 120 after we subtract that.
X equals 12.
Okay, how'd you get?
X equals 10.
Yeah, 12.
How would you get there?
Divide by 12.
Divide both sides by 12. Use x by
It's
itself.
not
They're
12.
multiplying, and so we'll divide. I'll move this over here since I'm kind of running out of room here. X would equal what? 10. And do we have to do anything else? Are we asked to find a specific angle measurement? No. Okay. So we're done once we found x.
Yep, yeah.
Could we check our work by plugging it back in and making sure we all have the 360? We could. Don't have to do that, but we could. That's kind of one thing, like I said, I say it time and time again, I love that about math, that you can kind of check your work, and you can know instantly if you did it right or wrong, and if you need to go back and try and fix something. So if you have extra time on a test, I understand not everyone does, but if you do have some extra time on a test, you can go back and you can kind of check your work, and that can help increase your grade as well. So a little trick there. Questions on number 2? Okay, we're gonna go down to number 3 then. Okay, so I want you guys on number 3 to find the value of x. I want you guys to try and do this one on your own. Okay, I want you guys to try and do number 3 on your own. And when you're done, or if you have questions, raise your hand.
Just 3. Are you done? This is me checking. What the?
No,
I don't know what it is.
Write it down, write it down.
Well, then you minus out.
I'm already
I'm gonna go see Gracie. Hi, Gracie.
You were trying to see? 70. Alright, calm down. That's the only one I have. So that's like a one. Here, got you. Just give me your phone. Just give me your social security number. You got it. Just give me your social security number, your first, middle name. Carlos? What's your middle name? No, bro, what's your middle name? Bird, like Miss Mom? Like Miss Mom? What? You look like the same middle name. Yeah. You 70? You didn't know that? Who's that? Mark? Let me see.
Give you email still for that? Switch your password from the email.
Are they?
I don't know what you guys overthink everything.
I'm afraid you can't for now. I'm afraid you can't.
My name stands for Andrea. And then just my cousin Bailey and my mom's name.
Okay, let's talk about this one up here. So, can I get some help in setting this one
I'll
up?
do it. You do
Billy?
it.
Okay, so you're gonna do 4 minus 2.
Okay.
And then times 180.
Okay.
And then it's 2 times 180, which is 360.
Okay. So what's that 360 represent, Lily?
That's all your angles added together.
Okay. Yeah, that's the sum of all of our interior angles here. It's 360 for a quadrilateral.
And then you do 80 plus 70 plus x plus 2x. And then then you get 150 plus 3x.
What's all this equal?
The interior angle.
So, what number am I going to put on the side of each side?
360.
Yeah. Thank you.
And then that equals 360 again, and then you subtract that by 150, and then break down 3x, you get 210, and then divide, get 70.
Very good. So we end up getting 70. So if we already know that a quadrilateral has an interior sum of 360, do we add to the first part? No. Is there anything wrong with doing the first part though? No. Okay. So if we do the first part, awesome. If you don't, okay. If you already know it's 360, you can just start here at 360. If you don't know and you want to walk through that, or if you just want to make sure, go ahead, walk through that. Make sure. That's fine. And so we got 360 there using our polygon interior angle sum.
You can see it.
A little bit. It's kind of blank and light. Yeah, and I got like something in my eye right now, so that's kind of bugging me.
It's an eyelash, the mascara.
It's probably my mascara. Yeah, probably.
I was thinking eyeliner.
No, that was last week. You know.
Opening, closing. Eyeshadow.
So, and then once we set this up, we set up all the 4 interior angles equaling the sum here. Questions on number 3?
Okay. Oh. I'm getting
Wait,
no.
no.
That's what it's opening, closing.
It always
Wait.
I don't have that
Yeah,
now.
it's the
Fossil.
I'll go with Just kidding.
That is not on my paper.
Okay, so Kennedy, you had this 150 plus x plus 2x, right?
Where's the 150 at?
Right here.
I had 150 plus 2x plus 1x.
Okay, and that's the same thing as this 150 plus 1x plus 2x. And what is 1x plus 2x? 3x. So that's 150 plus 3x. You had added up to 70 and 80 separately, and so we put that there. You had done that as a separate step and just put that there. Does that make more sense? You're saying that? Okay. On 4, the sum of the interior angles of a convex polygon is 1,260. Classify the polygon by the number of sides. So what are we trying to find this time?
Type of polygon.
We have to find the type of polygon. How can we figure out the type of polygon?
Math.
Okay, by finding the number of
Sides.
sides. So before we were given the number of sides, we could count it, and we found the sum and used that. Here, what are we given this time? We're given the sum. Very good. And we're trying to find the number of sides. So how we're going to set this one up is we're still going to have our n minus 2. I'm going to use a different color, actually.
Purple.
Sure. These are n minus 2 times 180. And what's this going to equal? 1,260. This works because this is the sum of any polygon, of any convex polygon. We'll find out. So we set this up because we said, okay, well, this will give us any sum. So if we just put the sum over here and have our unknown for n for our sides, we can start to solve this. How would we begin to solve this? William?
Subtract 180.
Okay, not subtract, but what are these doing?
Oh, divide.
Divide. They're multiplying, so we'll divide by 180. And so because this is multiplying, we can just divide that out there. We can divide multiplication. Well, if n minus 2 is equal to 1,260 divided by 180, which Randy said was 7. So now how do we get n by itself? Add 2.
I said it was 9.
And how did you know that, Gracie? Okay, how else did you know that?
I looked at my thing.
Okay, so what if we don't have our chart on our test?
Yeah, Gracie.
Okay,
You gotta do that.
then that's why we're going through that.
Come on,
So,
Gracie.
Now we found the number of sides. What were we asked to do with this number of sides?
Find the polygon.
Classify the polygons. Let's name what kind of polygon this would be.
A
Nonagon. Very good, Marley.
nonagon.
Nonagon.
Okay, I wouldn't have gotten it right.
You need to memorize
Will
them.
there be a word bank on the test?
We gotta memorize them.
There won't be.
This test is your notes.
I'll consider making a word bank for our names of polygons.
So like the nonagon and stuff.
I'll consider that.
Yeah, I think you should tell me this is a good idea.
What if I get, what's this test?
We have
A
one.
couple weeks.
What if I like do really well on it, but then I don't retake my other test that I just got 48% on? What do you think that even at?
I think you should retake that.
Well, can I do that like after this week because I was like a concert, so I'm doing study hall. So just can I start like next week?
Also, I'm in the first one.
I
I come in and study it all.
This week is busy. Sorry.
Let's go on to, well, first of all, excuse me, do we have any questions on number 4? Like how it was set up, how we solved, why we did what we did, any of that?
You know that you would.
What?
How?
No, like, with trees.
How did you know to get how to get 1260?
Yeah, how did we set this up? Okay, everybody listen up real quick. Gonna talk through the setup on this, and it won't hurt you to hear it again by any means. So here we knew the sum of the interior angles. Before we were able to find the sum of the interior angles using the side length. This time we're given the sum, and we're trying to figure out the number of sides. So we said, well, n minus 2 times 180, where n is the number of sides, always equals our sum. We said that back on the first slide here. N minus 2 times 180 was equal to the sum of the interior angles. So we have n minus 2 times 180 equal to the sum, but this time we know the sum to be 1,260. We don't know the number of sides. Randall, please stop playing with that. But we don't know the number of sides, and so that's how we set it up. From there, our algebra skills kick in, and we're saying, oh, well, we need to divide this multiplication and then add 2. Does that help answer your question?
It says in the problem that the sum of the interior angles of the convex curved polygon is 1260. So that's where is equal. So it equals 1260.
So then,
On this one over here, you didn't know how many, you didn't know what the interior was, right? On this one down here, it told you what the interior was. So it has to equal that, and you have to set up the equation.
okay,
Are you saying that?
Okay, we're gonna talk a little about exterior angles. Exterior angles. An exterior angle would be formed by taking the side of the polygon and continuing it on. What kind of angle would these two have to add up to?
80.
180, because that's the measure of a line. So that means this one would be what? 72. How can we find that? 180 minus 108. And that would give us 72. So if we continue doing that, this would also be 72, wouldn't it? Wouldn't it? It wouldn't change from here, what 180 minus 108 is. What if we do here?
What are you doing, Mr. Thomas?
Oh,
You had one jump. You had one jump.
Bonka S. Feels bad,
It'll be
man.
alright.
It's okay.
Been a pog though.
No.
So here, all 5 exterior angles would be 72. I want you to add those up. I want you to add up all 5 of those exterior angles.
72 times 5. Count that.
375.
375.
The sum ends up being 360 degrees.
wait a second.
Now,
Oh,
how many exterior angles did we do at each vertex?
1.
We only did 1 at each vertex, which gave us a total of 5 for the number of vertices. But we only did 1 at each vertex. If we went the other way with this, if we went this way, would we also have gotten 72 degrees right here?
C.
Yeah. So we could have gone the other way every time as well. And we got the same thing, right?
So our answer is
So-
360.
Our sum for this one is 360. So I need to write the sum is equal to 360 degrees on that first one. For the one on the right, this hexagon, this regular hexagon, I want you to go through and I want you to find the exterior angle measures for all of these, one at each vertex, and add them up as well. So I want you guys to go ahead and do that on your own. Is go through here,
I got it.
find this exterior angle measurement, and find one for each of these angles and add those together. So just like we did here, we found the exterior angle measurements, one at each vertex, added them together. We're going to do the same here.
What?
Just think that we got Spanish in the second one.
Thanks. We might.
So, yes, Spanish. Oh, yes, Spanish. What?
I'm sorry. I'm just tired and everything's
Gracie, you want
Yeah, hop off.
But that doesn't make sense.
I wish I could go iPhone. Oh, you too.
Alright, what did we end up getting this exterior angle to be? 60 degrees. We took 180 minus 120, and we got 60 degrees. And were they all 60 degrees? Yeah, because all of these interior angles were the same. It might not always be like that, but because it's equiangular, it is. Now, what did these add up to? What was the sum? 360. Well, that's kind of weird. This is a different shape. So we know that the interior angle sum is different, right? The interior angle sum of any two shapes can be different if they have a different number of sides. But the exterior stayed the same, didn't it?
Yeah.
Okay, the total number of interior angles here is 540, where the total number of interior angles, the total sum, is 720. But the exteriors were both 360. And that's not a coincidence. It's actually going to be like that all the time. So if we flip the page here, the sum of the measures of the exterior angles of polygon, one angle at each vertex like we did, is 360 degrees. So regardless of the number of sides, it could be 3 sides, a triangle. It could be 4 sides, a quadrilateral. 9 sides, a nonagon. 58 sides. It'll have an exterior angle sum, all the exterior angles will add up to be 360, as long as you only have one at each vertex.
So now we gotta find y.
So,
Easy.
here we have this polygon. I'm going to highlight it kind of in this orange here. We have this polygon. How many sides are there to this polygon?
4, 5.
There are 5 sides to the polygon, so it's a pentagon here. And we need to find y. Y is what type of angle? Interior or exterior?
Exterior.
It's exterior. It's outside the polygon. Interior is inside, exterior is outside. Okay, so we're given all the exterior angles, aren't we? And why?
No.
What do we know about these 5 exterior angles?
They're all gonna add up to 360.
They're all going to add up to 360. Very good. So what kind of equation can we set up? Can somebody help me, Gracie?
Add all of them.
Okay. So how would our equation look like?
70 plus 60 plus 60 plus 5. Wait. Plus y equals 360.
There we go. We add up all 5 angles to give us our sum of 360. So just like earlier, we added up the interior angles to get our interior sum. We'll add our exterior angles to get our exterior sum. But here, do you ever have to worry about what the sum's going to be? No, it's always 360 for these. Interior, it's different for the number of sides. Exterior, doesn't matter how many sides. It's 360. Kind of nice. Questions on the setup of number 3? Or number 5, excuse me. Okay, how do we solve this one? Or how do we finish solving this one?
Add them all together and then divide.
Okay, combine like terms. So 70 plus 60 plus 65 plus 40 is what? Thank you, Callie. And y ends up being 125. Questions on number 5?
Where did we get 235 back?
We combined all of these.
Isn't it 360?
All 5 of the angles equal 360, but these 4 that we were given plus are 235. So that plus y is 360. Does that make sense, Randall? Alright. Questions on this one besides what has been asked?
No, sir.
Thank Dope and Liddy.
Dumb lady?
Thank Dope and Liddy.
Dumb lady.
Oh, Dumb Liddy. Fire Festival. Okay. On 6, we're supposed to find a couple missing angles. How many missing angles are we supposed to find? Two. We have x and a y up there. Okay? So what kind of angles are those? Interior or exterior? Exterior. Okay? What do we know about the sum of the exterior angles of a polygon? That equals 360, right? Okay? William, you're going to answer that question, or are we going to try to go further?
Trying to go further.
Okay, what are you thinking?
Since x is, or since the interior angle by x is 90, we know that x is 90.
Okay? So the interior angle next to x or adjacent to x is making a linear pair with x to bring back some vocab is 90 from this box. We know that x must be 90 because they have to add up to 180. So we can take that 180 if we need to, subtract 90, and know this is 90. Okay, so that's one thing we could know. So we found x. That's kind of nice. So now we have to find y. Does anybody have an idea on how we could do this? William, what are you thinking?
We add up all the sides.
Add up all the.
Add up 90, 67, and 75.
Okay, all of those exterior angles.
And so you add them up.
Okay, so plus y. Did we get all the exterior angles? No, we're missing one, aren't we? Which one are we missing?
Y.
Well, we have y right here.
They're the same. That one.
How do we know these two are going to be the same?
Because the interior.
The interiors are the same, so the exterior have to be the same. Because regardless of what number these are, what measure these are, since their exterior angles both have to add up to 180 with them, they're going to be the same. Because if we just put in any random measurement here, somebody give me a random measurement just to see. 23, okay? So if this is 23, that means this is also 23. Well, how many numbers can you add to 23 to get to 180? Just one. You can't add two different numbers to get to 180, right? Besides 23 and one other number. Okay. Right. So 23 plus only one other number will get you to 180. It's not like there's two different options there. There'd only be one other option. So these must be the same. So we don't know that's 23 though. We just kind of put that in there, just kind of say, oh, well, what if? So we can say 90 plus 67 plus 75 plus y plus y again for both of these is equal to what? Very good. Questions on setting that one up? Okay, dang. So now we need to combine like terms. 90 plus 67 plus 75. 232 plus 2y, because y plus y is 2y. How would we solve this from here? Subtract 232 from each side. 2y will equal 128. And divide by 2, and y is equal to 64. So I'll probably just put these both up here closer together, just to make it a little easier to find my answers. You wouldn't necessarily have to. There we go.
We got one more.
We had Canes last night, so.
It's true. We'll talk about it.
What do you want? No.
What about Golden Dragon?
That's good.
No,
Oh, really?
I don't like how there's
Salsa.
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 I just said salsa.
Okay, this is Roadhouse.
Okay. Ooh,
Yeah, but we're poor. We're on our budget. Gosh darn it.
Then only get the rolls.
You can't just buy rolls.
Then you can.
Yeah, you can.
Why? Who buys just rolls?
My sister
Get a
does.
drink. Get a drink.
They just get all these rolls.
Yeah.
Maybe split an appetizer.
Just get water, and we can get the little potato skin thing.
There you go. There you go.
I could.
Okay.
Marley, your food.
That'll crack me up. You guys keep me young. The measure of one interior angle of a regular polygon is 108 degrees. Find the number of sides of the polygon. There are two ways to do this.
go?
Oh yeah. Oh yeah.
Go.
Oh yeah. Come on. Oh yeah. Okay. So let's think about. Take a second. Think about how you could figure this one out. I want you guys to think. I want you guys to stretch yourself a little bit. Think about this one. How could we figure this one out? Figure out the number of sides that are given an interior measure.
My brain can't.
Not true.
Did we already do this?
We're doing it?
No, we're thinking.
Does anyone have any ideas?
Open our notes.
We don't have anything yet, actually.
Then what are we thinking of? We don't know
We're
what we're
thinking of
thinking of.
using things we know to see if they can help us here. We haven't learned a strict way to do it yet. That's what we're doing.
How
We're
do they-
seeing if somebody can come up with something, an idea maybe, and can springboards to it.
We just do it to
108
number
times
6.
2 minus, and then subtract it out 360.
Alright, so say that again, Gracie.
108 times 2.
108 times 2, okay, so why multiply by 2?
Uh,
Alright,
never have sides to be the same.
the angles could be the same?
Yeah.
Right. Well, we know all the angles are the same because it's regular. So we know all the angles are the same,
We don't know how many sides.
but we don't know how many sides, do we?
You don't need it.
Okay? If we knew the number, what's 360?
If the angles are the same.
Outside angles.
Okay,
The
what was that?
outside angles are so if the angles are all 60 minus 108 and that's the. Never mind.
Okay.
You just said what?
So all the angles on the outside added to 360. Okay, I heard that.
Wait a second.
Do we know an exterior angle?
108.
Yeah.
Well, what's
Yeah.
as what kind of angle?
Interior, we can figure out the exterior.
Okay, how would we figure out the
180
exterior?
minus
Wait, listen up. Alicia was saying something, okay? Alicia, if we have an interior angle, how can we find an exterior angle?
180 minus 108.
Take 180, subtract 108, and we get what?
Oh no.
72.
72, okay? So now we know, we said that all the interior angles were the same. Do we know that all the exterior angles are also going to be the same?
No.
Yes.
No.
They're all gonna.
Okay, if we look at what we had earlier, when the interior angles were the same, like on those two Y's, on
Oh.
the last
yeah.
problem, the exterior angles were also the same.
Yeah.
So that means all 5 exterior angles are going to be 72. So could we take that 360 divided by this measure and figure out how many there were?
Sure.
Someone try that. 5 sides.
Pentagon.
A pentagon.
Knew it.
You did.
So there were 5 sides.
Mr. Castle. I used my notes and that's what I got.
Okay, what part of your notes did you use then? Oh, the table. Okay. So Paige, I get what you're saying. So Paige is saying, hey, I used that table here on the previous page, kind of right where we started today, Mr. Castle, and it said on here for each angle for regular polygon would be 108 on this pentagon. Okay, so we could use that part of our notes to kind of help us out as well. But once again, we might not always have our notes. Okay, but I get what you're saying. My bad, I misunderstood you here.
So that's one way.
So one way is to take the exterior sum, which is always 360. That way. The exterior sum, which is always 360, and divide it by what each exterior angle is. So because each exterior angle is 72, it works because it's regular. If each angle is not the same, it doesn't work. But because each angle is the same, we can just divide it by that and get it. Our other way, our long way,
Why do we need long?
if we don't remember this, would be to say, well, n minus 2 times 180 is equal to the what for a polygon?
36,
The sum of the what kind of angles? Interior angles. The sum of the interior angles. Okay? Sum for the interior.
Just right in.
Yeah, the sum for the interior angles. Okay? Now, we knew that we could take the sum of the interior angles. We said, hey, we can take the sum of the interior angles divided by the number of sides or angles, and we got each angle before. We did that last time up here in 6.1. We said, hey, if we take the sum of the interior angles divided by the sides, we got each angle. So we can do that again here. Say the sum divided by sides is each interior angle. Now, that means that what we can do is we can substitute this part for the sum. If this part is all equal to the sum, going back to Algebra 1 skills, if this part is all equal to the sum of interior angles, we can substitute that in where we have the sum of the interior angles in that second equation. If it's all equal to that, it's the same thing. So we end up writing all of this where we see that sum. So we do n minus 2 times 180, then parentheses, over, in this equation, the number of sides n is equal to each angle, which is 108.
This way's dumb.
Yeah, why would you do
I'm
that?
sorry you feel that way.
I kind of lost. No, I lost.
Why would you do all that work?
Because if we don't know this way, we can do this way too.
Do we ever need to know that way then?
You do
If
know
We
we
that.
need to
know
know
that
one or the other, and I'm explaining both.
Huh, does anyone want to know the
Just
second
let him talk.
Thank you.
Monka S.
How to get it?
What don't you get, Randall?
Okay,
I'll
we're
talk
done.
to Nathan.
Randall, put your head down, please.
Are we done with this?
Randall, put your head down,
I
please.
don't think we're that done with this.
We're doing the whole number section.
You're getting
Thank
kicked
you.
out of school.
Okay. Everybody listen up, please, and thank you. A few more seconds here, that's all I'm asking. Don't put everything away yet. A few more seconds here, that's all I'm asking. Okay, Donnie and Mr. Carlson, nice to meet you.
You forget the brain dead part.
Last name Brandon. Alright,
Got it.
how we would solve this one is a little bit tricky, but we would multiply by n on both sides. We're gonna, oh, that's n, and I tried to cross it out. So we can divide by 180 like we did earlier in one of these problems. Someone do 108 divided by 180. Randall.
6.6.
0.6 n now. Okay. Then we need to get all the n's together so we can subtract the n from over here. So if we subtract one whole n from 0.6, we'll have negative 2 is equal to negative 0.4 n. How would we get n by itself, Lily? What's negative 0.4 doing with n? Divide by negative 0.4.
How did you get negative?
So okay, I got 0.4 from taking 0.6n, and I subtract the n to get all of them together. So this is like a 1n. So if you take 0.6 minus 1, you get negative 0.4. Good question. Does that make
What?
more sense?
Yeah, you see that? Wouldn't it be fine?
Wouldn't what be 5?
Yeah, it'd be 5. Yeah.
Six
What would be five?
n minus one
Yeah.
n would be 5.
0.6n. So like 0.6n.
Oh.
Yeah, good question. Okay. I know what you're saying.
Yeah,
So
yeah.
0.6n subtracting a full n would be negative 0.4n. So now if we take negative 2 divided by negative 0.4, you got that, Randall? Negative 2, negative whole 2, divided by negative 0.4.
Ah, 5.
We get 5. Hey, did we get the same thing?
Yeah, just
Woo! Okay,
Mr. Costle's boy wouldn't say blue.
let me recap this real quick.
no, it's
Okay.
Yeah, I can do that now. When you explain two different things, it's like
I'm
confusing.
recapping the problem as a whole. Bless you, bless you, bless you. Okay, thank you.
Monka S.
Alright, so, listen up. Focus back in for like another minute. All I'm asking right now.
These have
Okay? Randall, stop. Lily, what's up?
Nothing, I was
Okay, gotcha. So here, when we're trying to find the number of sides and we're given one interior angle, if we want to, we can set up this way in the blue. We don't have to. If that's the way our mind works, some people find this one easier. They do. You might find that weird. Some people actually do find that easier, which is why I went through it. Sorry. I thought the door was unlocked, so I was going to grab it for you. Right? So some people actually do find this blue easier. Believe it or not, that's the case sometimes. Or we can go through in the dark blue, which it seems like most of you found easier. That's okay. And we take the exterior sum 360, divide it by the measure of each exterior angle, which is 72, which we found by taking 180 minus 108. Because every interior angle and exterior angle form a linear pair. And we got 5 sides, which was what kind of shape? A pentagon, which is a type of polygon, just more specific. Alright, so we have about 11, 12 minutes here.
What?
So we can get a head start here. Yeah, Randall, what's your question, buddy?
If,
Not like real food.
if it was like, on number 7, if it was like outside, like
An exterior angle?
how would you find that?
Okay. Hey, Randall had a good question. And that might also be helpful for your worksheet. Let me put it away. Let me put it away. Thank you. Randall had a good question. If we were given an exterior angle on number 7 instead of an interior angle, well, what did we end up doing on number 7 in the dark blue? What kind of angle did we find when we were given the interior angle?
Exterior, interior, exterior.
When we were given the interior, we found the exterior. So if we're already given the exterior, you don't have to do that step. You can just take 360, the sum of the exterior, divided by that angle measure. And boom, you're right there. So you save yourself a step if you're already given that one. Because we went through and found it. Does that make sense?
Yeah.
Okay. So, on this worksheet, start off finding a bunch of angle measures on the front, on the back, doing more angle measures. Woo! Everybody go stupid. Ah! Go crazy. Ah! Go stupid. Ah!
That made my whole day.
I'm just
Wait,
I
how
just-
do we do the first?
Oh,
wow.
What's our non-agone?
So the first one's n minus 2.
No, you gotta
Five
go.
minus
Oh,
like that.
man, messed up. Don't slide.
Five
Boom,
minus
boom,
two.
boom.
Pentagon has approximately 5 sides.
What's our non-agone? Mr. Cost, what's
No,
our
I'm going this. I'm going
Nine.
To simplify
Thanks.
5
9 minus 2.
Mr. Cossel?
Yeah.
After like you multiply
Okay.
and